Hi, I'm Phil. I'm one of the co-founders here at AttackForge. Today I'm going to show you how you can connect your AI agents and tools to AttackForge to create agentic workflows. There's 5 workflows that we're going to cover in this video, which includes launching AI hackbots to perform a penetration test, enriching vulnerabilities using AI, analyzing findings and creating attack chains using AI, creating an executive summary, again using agents, and also launching more hackbots to perform a retest. We now have over 60 MCP tools in AttackForge, which means you can practically do almost any agentic workflow you can think of. So let's start with launching agents to do a pen test. On my project, if we check the scope page, we can see that there's one asset assigned to the scope for this project, and it's a web application. I'm going to click on test cases, and here we can see what the agents will be testing. Each test case has built-in instructions and guardrails to ensure the testing coverage is tailored to my needs. I've loaded the OWASP Web Security Testing guide as the methodology for my agents to follow. AttackForge comes with the Web Security Testing guide already built in, as well as dozens of other methodologies from OWASP, MITRE, such as the Attack Framework, Atlas Framework, OSS-TMM, and so on. You can also build your own completely custom methodologies in AttackForge, which are built to suit your needs. So let's open a test case and take a look. So here we can see exactly what the agent's going to be doing. It will be performing a search engine discovery reconnaissance for information leakage. And if we scroll down, we can see the test objectives and other useful information that will be helpful to the agent to know, as well as what we consider to be a pass or a fail. And also the different tools that the agent can use and the detailed execution flows which will guide the agent on exactly how the test should be conducted. So now back on the test cases table, I'm going to select a few of these test cases, and I'm going to, using the actions menu, click on a custom action called Launch AI Hackbots. So I've built this custom action in AttackForge and tailored it for this particular workflow. You can really build whatever actions you desire in AttackForge directly in the UI. For more information on how to create and configure actions, please check our support site. So here we have a custom form which I've configured for our hackbots. It asks different questions such as, what type of testing do you want to do? What level of testing coverage is expected? How autonomous can the agent be throughout its testing? What are the permitted actions? And also what's prohibited that we don't want the agent doing? What are the different severity schemes that we want the agent to follow? And what are the evidence requirements that it's expected to capture? So this information will determine how my agent should act when it's performing this test. So let's go ahead and run this. So what just happened now is this action has kicked off a flow. If we open the flow, we can see exactly what was triggered. So let's go ahead and do that. So Flows is AttackForge's workflow automation engine. It's incredibly powerful, and it lets you create almost any workflow you can imagine. It's backed by AFScript, which is AttackForge's easy to use scripting language. And for more information on Flows and AFScript, please check our support site. So we can see here that there was one HTTP request which was made. And if we open up the details, we'll see that it went to our OpenClaw instance, which is running our hackbots. We can see that the test cases that we were sent to the agent along with the project ID itself. So agents are doing. So here we can see there's a combination of the main agent and sub-agents. And if we open up the main agent, this is the one which was triggered from the AttackForge flow. And we can see here that it received an instruction to do some testing on 3 test cases. And from here, it's went and spawned its own sub-agents, which each sub-agent will perform testing for each individual separate test case. So now if we come back to the overview, we can see each of these sub-agents which are currently testing. And we can drill down to see the exact information for what the agent is doing as part of this testing. And here it's using the AttackForge MCP tools to retrieve information about the test case. It will then build a test plan using the information and guardrails contained within the test case. And it will then execute on that test case and capture that test plan information against the record in AttackForge. And then any vulnerabilities it identifies, it will then create them in AttackForge, and we'll see those hopefully shortly. And it will then link them back to the test case itself. So now let's go back to AttackForge. And if we refresh on this page, we should see now that one of the test cases are in progress. And indeed, we saw the sub-agent has already kicked off the testing for that. Now, let's give it some time to finish testing. Okay, it's been about 15 minutes now, and the agents have finished testing those 3 test cases. We can see that some vulnerabilities were discovered, and as a result, 2 of those test cases have now failed. Let's take a look at the test cases to see what the agent reported. So we can see in the notes more information about the evidence that the agent captured during testing execution. We can see the methods which were followed, the results from the testing itself, even the outcomes as a result to the pass or fail expectation. And we can also see that a finding was discovered. Now, if we click on vulnerabilities, we can preview those findings which the agent created and then link to this test case. And inside the vulnerability, we can see all of the information that the agent added, such as descriptions, attack scenarios, remediation recommendations, and importantly, the steps to reproduce or proof of concept. So we have evidence from the agent with regards to this specific vulnerability itself. If you pause and think for a moment, what just happened? We kicked off a workflow with custom parameters to trigger an agent to perform a test. The agent then fetched and interpreted the test cases. The agent then created test plans, and the agent then executed on those test plans. It then recorded the outcomes on the test cases back in AttackForge and wrote up all the related vulnerabilities and then linked them to the test case so it failed. This would have taken a human considerable time to do the same. Now, if we extrapolate that against the 108 test cases assigned to this project, this is where you start to see significant time savings as a pen tester. Now we're going to switch to another project. Now, if you're not a fan of giving agents structured test cases to follow, that's not a problem. Here's an example of a test where the agent was told to do a pen test using OWASP Web Security Testing Guide, and that was it. It was given freedom to explore, poke, and prod. However, we did request the agent that when it finds a vulnerability, that it also creates an associated test case, so we know exactly its reasoning that led to that vulnerability. So let's take a look at one of those agent-derived test cases. So here we can see exactly what tests were performed by the agent. We even have a finding summary and the execution flows that the agent followed when it was performing this test. It even created some additional notes with references back to the vulnerabilities that were created. So now let's go back to our first project and let's pretend that the vulnerabilities have now been fixed. So now we're going to select the vulnerabilities and mark them as ready for retesting. And we can see that in the status, these vulnerabilities can now be retested. So we're going to go back to our menu and we're going to select AI retest. And we're going to launch this flow. And we'll see that now if we jump back into the OpenClaw control UI, there is a new agent that's just been spun up to start working on retesting those vulnerabilities. Okay, so it's been about 15 minutes now, and the agents have finished the retest. We can see that one of the findings failed retesting and was subsequently reopened. We can see the other two vulnerabilities were fixed and closed. Let's open one of the findings and take a look. So in this vulnerability, we can see that there was a number of different files which were exposed during the initial testing. And if we open the remediation notes, we can see here how the agent had performed the retest, documented all of that information and evidence, and subsequently closed the vulnerability. So we have clear visibility on how the agent performed the retest, as well as the evidence which was captured. And this gives us confidence that the agent had retested this vulnerability properly. Retesting is one of the biggest time sinks in pen testing. Sometimes you spend more time setting up for a retest than actually doing the retest. So by offloading retesting to AI agents, this significantly reduces the amount of time spent on context switching between testing and retesting. And it also makes the retest process much faster and easier for everyone involved. So let's switch it up a bit. Let's take a look at a vulnerability which is in desperate need of enrichment. Here we have an XSS vulnerability. It has a pretty crap write-up, to be honest. The description, attack scenario, and remediation definitely needs a bit of love. You wouldn't give this to your own mother, let alone to a customer or an internal colleague. But I'm a pen tester and I'm generally time poor, and most of all, writing sucks. So let's kick off an agent to fix this up for us. So from the actions menu, I'm going to click Enrich Vulns with AI, and I'm going to run that. So what's happening now? Well, enriching a vulnerability doesn't require access to an operating system and local tools such as the pen testing and retesting workflows we just saw in OpenClaw. In fact, we can rely on AI models with web access alone. So this is Copilot Studio, a place where we can build agents and link them to workflows, which we can then trigger from AttackForge using flows. If we open agents, we can see there's already an existing agent called Enrich Vulns. And if we open this agent, we can see that this agent is connected to Claude Opus 4.8 as its model. If we click on Tools, we can see that this agent is also connected to the AttackForge Remote MCP server, so we can communicate back and forward and work with AttackForge. There is an article on our support site which shows step-by-step how to configure MCP on AttackForge and how to integrate it with common AI tools, including Copilot Studio. Now let's click on Flows. Not to confuse Copilot Studio flows with AttackForge flows, both are workflow automation engines. We're going to click on the Enrich Vulns flow. And if we click on Designer, we can see briefly how this flow works. So it's a two-step flow. The first step is to receive a HTTP request, and in this case from the AttackForge Flows engine. It then authenticates against the allowed users, validates the payload, and then passes this to an agent to then perform the task. Let's click on Activity to see if our agent is finished. So here we can see that the agent has finished the enrichment task. And if we open up the agent, we'll be able to see exactly what it did, including the prompt that it was given and the results within the activity page. So here we can see the entire chain of events. It's very similar to what we were seeing in OpenClaw. We can see that the agent received a trigger to perform a task, and from there, it was then using the AttackForge MCP to find more information and context about the vulnerability that it needed to enrich. And it was then learning about the vulnerability and all of the fields and custom fields, as well as the structure and of what the MCP tools support. So this really helps make it easy and predictable for agents to use our MCP server. And after enriching the vulnerability, it made a patch request back to AttackForge to update the vulnerability with the enrichment details. So now let's take a look at the vulnerability. So if we refresh the page, and we'll give this a moment to load, we can see that the XSS finding looks significantly better. We have a meaningful description. It's created references back to industry frameworks and identifiers like CWE and CAPEC and back to MITRE. It's created an attack scenario, and it's also created some remediation guidance for us as well. So that's how easy it is to enrich vulnerabilities using AttackForge and Copilot Studio. Although if you're in AWS or GCP, you can connect directly to your Amazon Bedrock agents or to Vertex Agent Builder directly from the AttackForge Flows engine. So now let's switch it up again. An important part of every pen test and red team assignment is to create a focused narrative which gets the attention of the people who are responsible for the vulnerabilities and gives them a reason to care about fixing the most important vulnerabilities that you worked hard to find. And one of the most effective ways of doing this is by creating attack chains. Attack chains has been a staple feature of AttackForge since around 2017, so almost 10 years ago. However, it's always relied on human intelligence to build these attack chains. So fast forward to 2026, we now have capable models which can reason about the vulnerabilities and data on a project and work out the possible attack scenarios which have the most impact. This is an example of an attack chain which was built by an AI model using one of our AI skills that we developed for creating attack chains. The AI was pointed to an AttackForge project, which was this project right here, and given these vulnerabilities which were discovered. It extracted all of that data and worked out what was important, what was not, and how we can achieve total compromise of the internal corporate domain using vulnerabilities found on the project. So you can run each simulation to see how it goes from initial starting point to achieving the objective, exploiting the vulnerabilities along the way. Now, if you click on Best Fix, it will show you exactly where to focus your remediation efforts to best break the chain. And the best part is you can create these attack chains using AI agents by just clicking a button in the AttackForge project and getting the agents to do the hard work for you. So this saves a huge amount of time when it comes to analyzing the findings and writing up the attack chains manually. You can even do this midway through an assessment to get some ideas from the AI on where you may want to focus your next attacks. So, switching it up one more time. So we still need an executive summary. We have all of the data we need on the project, so why can't an agent just write the exec summary for us? Well, it turns out they can. So I'm going to click on the reporting tab, and here we can see that an agent has went and created all of this information for my executive summary for this red team assessment. And all I had to do was click this one single button to make that happen. Now, this saves a huge amount of time at the end of every assessment where this information is usually manually put together. You can use these agents to get the initial version ready for your review, and then you can focus on adding the human touch. So, as a summary, combining AttackForge with your AI tools and agents can save your security team huge amounts of time and energy for almost every phase of the pen test lifecycle. If you're an internal enterprise security team, this really stacks up when you scale it out to dozens or even hundreds of assessments per year. And if you're an MSSP thinking of giving your customers a portal where they can deliver agentic testing and you can offer them self-service, perhaps give AttackForge a try. Combining actions, flows, and MCP, you can build almost any workflow you can dream of and automate it with some agents. I hope you enjoyed this video. Make sure to follow us for more exciting videos where we make pen testing and red teaming less crappy. Thanks for watching.